Good morning, my name's Dave Kenworthy, and we're having a change of tack today. We're going to look at the paper by Australian mathematics professors Wildberger and Mansfield in respect of Plimpton 322. I've got the paper up here, and this paper is so important in setting the level at what these Neolithic farmers were operating at. Now, these professors have discovered something about this Plimpton 322 Babylonian clay tablet. They've discovered an interpretation that takes the level that these people were operating at up in beyond the stratosphere, as far as I'm concerned. And we can look at what they've actually done to summarize the information on the tablet, because it's in Pythagorean triplets. And so the association with Alexander Thom's work is very obvious. Thom insisted that these people were deliberately using Pythagorean triplets to produce astronomical and geometric information. And that's exactly what we're finding on this tablet. And when the two professors presented this tablet, and I watched it on YouTube, if ever in my life I saw two professors who were actually stunned by their own discoveries, it was these two, because it was almost like they couldn't believe what they've discovered, because it is so far out. It's so far out there. It's just unbelievable. And I just got to say thank you to both of them for doing this work and presenting it in the way that I can understand it, because it's such a complicated paper. But they've narrowed it down really to one table. And here we go. Let's have a look at it if I can find it. I should be able to. That's it. Oh no, that's not it. That's table 9. We're looking for table 13. It's a huge amount of work gone into this. I can't really imagine how they actually put all this together. This is professional scholars, so this is the work of the highest level professional mathematics professors, and this is what you get. You get your money's worth. So this is table 13, and there are 38 rows in this table. And they're all Pythagorean triplets, and what they're looking at is this number here. And that is being produced by these two numbers here. So if we divide that, are they? Oh no. Okay, let me go back. That is the long side. So what I've done, let me get this, a long time since I did this. I just pull this file out and start talking about it, and I don't really know what I'm talking about. Let's have a look what I've done. I've worked out the opposite side here. Now, they've produced the diagonal, and my approach is to produce the diagonal having worked out the opposite side. So what I'm going to do is, using a Pythagorean triplet, that is the adjacent side, that's the opposite side. And the diagonal will be that squared plus that squared, and the total it'll be the square root of that total that goes in here. And it's pretty easy to do that, so let's do it. There's one. That's 119 squared. And that's 120 squared, which is 12 twelfths. So we have to add these two together. 28561, and then we need to take the square root of that. So we go to formulas, insert function, square root, click on square root, and then we click on that because we want the square root of that number. And there it is, 169. Automatically goes in there because this is preset. We can do the whole table now. So we just go across there like that and then drag this down. And that'll do the calculation for the whole table. And what we find is, this is the diagonal here, and I've transferred it to there. So this is the Pythagorean triplet. And what is so stunning about this is that every one of these is a whole number. So these people have prepared a table of values, a complex table of values using Pythagorean triplets. I mean, I can't even describe how complicated this is. It's just beyond anything that you could ever come across. I mean, what kind of reason would they have to do this kind of stuff? But what it shows us is they were manipulating big numbers here. Look at these babies. Look at this. Look at this. But what we find in this table is, I am so familiar with all these numbers here. I know all about them because I've studied historical metrology. You see that number there, 6561? Well, Egyptian pi is 20736 divided by 6561. Let's work it out. That's 316.04938. What a rotten number. But that is not a rotten number. That is it's 4 over 3 times 4 over 3 times 4 over 3 times 4 over 3. So 256 over 81. Boom, boom. This is one of the most important numbers in Egyptian mathematics, and we're finding it in this tablet. It's nothing to do with Egyptian mathematics, and yet it's there. You know? 20736, there it is. 6561, there it is. What have these professors discovered? They've completely opened the door to ancient mathematics. It's absolutely stunning. I'm going to have to stop. I'm getting a bit too excited. Thank you.